Hello, welcome to this short video tutorial, the purpose of which is to guide you through using the Tilia software to produce stratigraphic diagrams, which you'll need for your Skills for Geographers Environmental Reconstruction workshop reports. You generated the data through the lab classes and in your own time, and then just show you now how you go about actually plotting that data up into a neat and tidy diagram that you can use in your reports. So this is Tilia, pretty obvious. First couple of menus over here. Let's open the file. So go to open, as you might expect. Navigate to where the file is. In this case, I've got the group A, Skills for Geographers Group A file. Tilia reads .tlx files. It reads its own particular types of files. TLX files are the spreadsheet files. The TGX are the graphics package files. So we'll start with the spreadsheet file, the TLX file. It's looking for a Tilia. You can see down here it's looking for a Tilia spreadsheet. It can look for some of these other things as well, but we'll just ask it to look for a TLX file. So here's group A, and we'll open that, and that should appear as if by magic. Let's maximize that so we can see what we're doing. So this is the Tilia spreadsheet. You won't really, for Skills for Geographers, you don't really need to do anything with this. All the data you need is in here already. I'll just talk you through all the different components. It says up here pollen. Don't panic about that. The software is designed for pollen analysis, so it's just pollen in the top left corner, but that doesn't really make any difference. The data, each sample is basically in a column, and the variables are in rows. So here, these are your samples. On the top row, these are the sample depths. So each sample is on here, and these are the variables that you measured. You've got percentage loss on ignition. You've got magnesium parts per million, silicon parts per million, potassium parts per million, calcium parts per million, titanium parts per million. So this is the loss ignition data. These 5 variables are from the XRF analysis. All the data's in here. You don't need to do anything with that. It's ready to go. Okay, so that's the spreadsheet. The other side of Tilia is the graphics package to make the diagram. See what it looks like. You just click on this button here, make the diagram. And here it is. So this is the graphics software. Defaults aren't great, so you'll probably want to change some of these things. Some things that definitely need changing. Okay, first of all, the y-axis. There's no units on here. It just says depth. So let's go change that. So click on the y-axis button. Brings up the y-axis dialog box. This name box here is going to be what ends up being plotted on the y-axis. So depth is in meters. So we'll OK that, and that will appear over here. The scale on here is a little bit odd. So we'll go y-axis again. It's the tick marks that's the problem. So we'll go on the tick marks tab, and the number of decimal points. So at the moment, 0 is selected, but because these are in meters, so they're 5.85 and 5.90 and these sorts of things, we need to express that to 2 decimal places. So 2 decimal places in there, and that should resolve all of that. The tick marks, sensible tick marks there. You can change that, but they look okay. They're far enough apart, and you can read those. That's fine. Next thing to do, when Tilia imports some big numbers, like for example, silicon parts per million is in the hundreds of thousands, it by default divides it by either 100 or 1,000 or something to make these numbers on here a bit more legible, but it doesn't tell you what it's done. So you need to go in and have a look at that. So how do we do that? We'll go into the x-axis. The x-axis button here brings up the x-axis dialog box. Again, go tick marks. First of all, select the variable. So which variable do we want to look for first? Let's go silicon first. So check on silicon. Okay, the tick marks. Okay, these are divided by 1,000. So these are really 300,000 parts per million down here. So divide by 1,000. Okay, that's fine. Happy with that? That looks neat and tidy. That's fine. We just need to remember that's divided by 1,000. We'll select another variable. Let's have a look. Magnesium. So select magnesium deselect silicon, have a look, tick marks, and this time it's divided by 10. Now that looks a bit jumbled together. If I divide that by 100, I think that will make those a bit more legible. Everything will be a bit smarter. So if I click on apply, and I can see that there. So that's divided by 100. The next one, let's go deselect magnesium. Let's have a look at potassium. Okay, tick marks. That one's divided by 100, so that's fine, and they look nice. Let's deselect potassium, have a look in calcium. They're only divided by 1, but these numbers are a bit squished up here. So let's keep things simple. Let's divide this one by 100 as well and see what that looks like, and that looks nice. Okay, you could have divided that by 10, but keep things as simple as possible. And deselect calcium, have a look at titanium. And again, that's divided by 1, so let's divide that this time by 100. And again, that's tidied that up quite nicely. So they're all, apart loss and ignition, their percentages, they look right, so that's fine. We can just check. Tick marks divide by 1, so that's fine. The others, though, they're all divided now by 100, except silicon, which is divided by 1,000. So to make sure that they're reading these are in or we're saying that these are expressed in parts per million, but these aren't parts per million numbers down here. So we need to write something on here so that the reader knows what the actual numbers are in parts per million. Okay, so we need to add some text down here. If you click on this button here, that's the interactive text. It gives you a cursor, and you drag that down there and have a look at it. So we'll place some text down here. Now the magnesium, that was times by 100, so text. Well, it's divided by 100, so to get the right answer in parts per million, we'll times that by 100. And if we OK that, that'll bring some text up there. That text is too big and it's in the wrong place. It's sat over my label now. The quirk of the thing, you don't go back into the interactive text. To edit that, you go into the text button. And the text button under random text, that's this one here, times 100. Minus 0.56, if I put that at minus 0.7, I'll probably shove it down enough. We'll click on that drop down box, click on this drop down arrow here, and that gives us the font size. It's 36 at the moment, we'll go 25, OK that, and OK that, and that's moved that down nicely, and it's now the right size as well. You can repeat that for these other 3 curves as well. The silicon is different, obviously, so I'll do that one just to show you that again. So times by 1,000 this time to get up to parts per million. We have that at the same height, so minus 0.7. I'll change that to 25. OK that, and that's there now. Okay, and for completion, we should put times 100, times 100, times 100 down here as well. Change that again to minus 0.7. Again, minus 0.7. 25. And lastly, it's 25 again. Okay, so now we've got these plotted up. We can see the numbers; they're legible. We can actually we've noted, what you need to multiply these by to actually express these in parts per million. So that's fine. Okay, as in terms of presenting the curves, that's fine. What you need to do though, the loss and ignition data, the XRF data was all in the spreadsheet. Your Troll-Smith description, the data that you collected in the lab class, is nowhere to be seen. We plot that up in the graphics package, and you go to this yellow button over here. When you hover over the other buttons, it tells you what it is. When you hover over the yellow button, nothing happens. Okay, but there is the lithology button. So you press that and it brings up the lithology dialog box. And you plot in your lithology. So that your the composition is the key thing, the composition from your Trollsmith description. So the top of this core was most likely the lake mud limus detritus is in the Trollsmith system. Our lake gutias. So the top of there, what's that? The top of the diagram, what's that? 5.81, something like that. And that probably went to about 5.95, I'm guessing, just from there. If that was a sharp distinction from the upper unit to the lower sedimentary unit, I click on here, lower boundary. That's the depths, and I also want to say that it's limus detritus. That's limus detritus LD. And if I click on that one, this is just the density of the pattern, so that's more dense, obviously that's less dense. It's easier to see actually if you use the least dense pattern. There is a reason for that in Trollsmith, but I'm not going to explain that. You need to know. It's easier, more visible if you just use the least dense pattern. So we'll use LD1. And over here now is a little preview of what that should look like on the diagram. So you're happy with that. It's the cross hatch for lake mud, and here's our lower boundary sharp distinction line. Okay, you might think you just click OK. If you click OK there, nothing happens. How annoying. Let's do it again. What you have to do, and you'll only make that mistake once, 5.81, what did we say, 5.95, click on the lower boundary, LD1, you have to click this post edit, this little green tick box in this little window here. It says no data to display. If we tick the post edit box, that little green tick, that then goes down into here. And now if I click OK, now it will appear. Let's complete that. So the next one is at let's say 5.952. What's the bottom of that? 6.2. There's no lower boundary. It's clay. Clay is Argilla steatoides. These are the little L signs. Click on the L there. The green tick again, just to post that down here. And if we OK that, and that should appear down there. If there's some overlap, if you want to suggest there's some kind of overlap in there, let's go here, let's go back here, and we can just overlap these. So let's say actually our lower unit, we can change that, our lower unit, we can change that to 5.92. And if I click OK there, then that's drawn those up there. It looks a bit silly with the lower boundary marked in so clearly, so let's uncheck that box. And now there's our transition mix of lake muds and silty clays. Up here it says lithology, but that's really because it's written by a geologist. We don't really have any rocks in here, so it's not that I prefer the term stratigraphy, so I'm going to change that to stratigraphy. We were in the lithology, we're working in the lithology dialog box, we're working on the design tab. If we go onto the options tab, where these things are, here's the title here, lithology, let's call that stratigraphy. Let's just check the size of that. And we'll go, 18 is a bit little, let's go 25. And all these other labels are at 45 degrees, and this is horizontal, so let's change that to 45 degrees just to make the look the same. If we OK that, then that's changed that. So now stratigraphy at 45 degrees. We haven't got a key, we don't know what these things are, so we can plot that. Again, we go back into stratigraphy dialog box, go to options, import lithological units. If we leave these blank, Tilia will just put these in the best place that it thinks. By default, it puts them in a sensible place. We'll call this lake mud. We'll call that clay. You can call that whatever you like, really, as long as it's accurate. So lake mud and clay. And if I check here where it says plot lithology key, then that will actually plot that as well. If I OK that, then they appear down at the bottom of the diagram here in the key. So that looks quite nice. The next things then is just what the diagram looks like. You can change some of these things if you go into graph style. You click on that. If you go on the select variables, it opens that. You can select all, or you can just select one at a time, whatever, select all. You can change those to hollow. If you apply that, you get a look and see what that looks like. You can have those as histograms. Let's go back to hollow. You can have patterns if you want. Depth bars, line graphs with a symbol to show you where the data points are. Sorts of exciting things. Okay, so it's really however you want to do, however you want to draw those things. Over here, if you've got these kind of in silhouette, you can change the color of these things. So there's all different colors. Those as teal, if you like, whatever. Just think what that's going to look like as you print that out. Sometimes it's nice to have different variables, different color, or similar variables in the same color, just to highlight things. That's up to you, just what it looks like. That's okay. Let's keep that there. Okay. You might choose you want to put these in a slightly different order. If you want to do that, you can go onto the variables box up here. That opens the variables dialog. If you just want to move calcium, for example, and you want to put that next to loss on ignition, you select calcium and you use the up and down arrows to move it, bump it up and down the diagram. So I've put that now next to loss on ignition. If I OK that, it switches from it was there, it's now here. The others are still in the same order, obviously. Be careful in the variables box. You can accidentally click on skip, and then that diagram disappears. So for your environmental reconstruction workshops, you want to be presenting all this data. So don't skip any of those. Zones is probably the last thing to talk about on here. If you want to add zones, you can do that with the zones dialog box. I'm gonna pick the wrong level, so I'm not giving anybody any clues. I'm not helping out Group A or whoever. I'm going to say my first zone is down here at 6.15 meters. So I type in there the level here at 6.15. The style here, you can have a line or a screen, that doesn't really matter. The options, you can have various dashed lines, little dotted lines, whatever. Let's go for a solid line. You can change the width of that, but hairline works well. Okay, that. And if I apply that, then you should be able to see that. Oh, what I haven't done. It's the same with the stratigraphy. You have to move that down from here down into here so that at the moment it says there's no data to display. So again, I have to tick this little green post edit, and then that goes down in there, and if I apply that, that will appear down here. Okay, so that appears on the diagram. By default, that zone line is always sent to the back. So you click on the drop down arrow there, and if you select to front and apply that, that should move that through to the front. That doesn't really matter if you've got solid curves, but if you had a hollow or a different kind of silhouette, that might be significant. Okay, so I'll just show you how to do that. And lastly, then you want to label those. You want to include the labels. So click on the Labels tab. If you click on this little button here, the stripy thing with a little red arrow on there, that imports the levels from the Levels tab sheet. And we get two zones, because you've got one zone line, that gives you two zones, an upper zone up here and a lower zone at the base here. and your labels, you put your labels in here. We start our stories at the beginning from the base, so we'll number them from the bottom up. So the lower zone we'll call 1, the upper zone we'll call 2. If I apply that, that should appear down there. Zone, if we go to the column title, again I'll put that at 45 degrees and I'll change the font size to 25 so everything's the same. If I apply that, that should do that there nicely now. Okay, I think that's all that you need to see. There's lots that you can play around in here and see what other options you want to do, but that's now looking like quite a nice and presentable diagram. And hopefully you should find that pretty easy and pretty straightforward to do. Output. How do you get this? There's no printer on the. There's a printer next to the computer in the laboratory, but it doesn't work, so you can't print this out. In Tilia, you can export it, but it exports it as EMF files, which lose some resolution. They're not great. They're not great to work with, so I wouldn't advise that. Rather, in the lab computer, you can, if you go on the Windows button, you can find the snipping tool, and I'd use the snipping tool to cut out the diagram, leave behind all the menus and stuff. Just trace round where you want the diagram and cut that out with the snipping tool, and you can save that as a JPEG, and then obviously with JPEG you can work that straight into your report. That should be fairly straightforward. If you have any problems, any questions, any queries with Tilia and using the software, you can speak to me or the lab technician Tom. He's used Tilia quite a bit as well, so you can ask either as questions. We'll be able to assist and help you out. But hopefully you should be able to do everything you need to be able to do if you just follow the instructions in here. Okay, so hopefully you'll have fun's probably the wrong word, but a bit of fun putting some diagrams together, make them look nice and neat, change the appearance of those, and have them looking the way that you want those to look, and then you can have those nicely in your report. And I'm looking forward. Had a look at the data. It looks really interesting. So I'm looking forward to reading what you've got to say, your interpretations, what you think might be going on in your report write-up. Okay, thanks for listening. I hope you found that interesting. I hope you found that useful. And good luck with those, and good luck with your final report write-up.